Find the area of polygon ABCD in acres. In this problem, points A, B, C, and D form a closed traverse, where the enclosed area is to be determined. A table of surveyed data provides the azimuth values and lengths of each of the four courses in the traverse. To find the enclosed area, we'll use the double meridian distance method, where the area equals 1/2 times the absolute value of the sum of the latitudes times the double meridian distance values for each course in the traverse. In plane surveying, latitude refers to the northward distance covered when traversing a course. From the figure, we notice the latitude of course BC is much greater than the latitude of course AB. Both of these latitudes are positive, whereas the latitude of courses CD and DA are both negative values because these courses traverse in a southward direction. The latitude is computed as the length of the course times the cosine of the azimuth of the course. The double meridian distance of a course equals the double meridian distance of the previous course plus the departure of the previous course plus the departure of that course. However, for the first course, the double meridian distance simply equals the departure of that course. And the previously mentioned equation applies to all subsequent courses in the traverse. The departure equals the length of the course times the sine of the azimuth of the course. Therefore, the departure equals the eastward distance covered when traversing a course. From the figure, we notice the departure of courses DA and AB are positive, and the departures of courses BC and CD are negative. From here, we'll add columns to the table for the latitude and departure. Next, we'll calculate these latitude and departure values by multiplying the course length by the cosine or sine of the azimuth of the course. These values are then returned to the appropriate columns. Next, we'll add the latitude and departures for each course to confirm the traverse closes. As it turns out, the sum of the latitudes and departures are 0.31 feet too far north and 0.07 feet too far west. This means if we start at point A and traverse along all courses, then we'll end up at a point we'll call A prime, which is located 0.31 feet north of point A and 0.07 feet west of point A. Therefore, we'll have to adjust the latitudes and departures in an equal yet opposite direction of the air enclosure to correct for the air enclosure. Using the compass rule, the adjustment for the latitude and departure of a course equals -1 times the course length times the air of closure for that direction divided by the total length of the traverse. In this equation, we know the air of closure for both latitude and departure. We can calculate the total length, and we know the length of each individual course. The adjusted lengths to the latitudes and departures are calculated, and we can compute the adjusted latitudes and departures by adding these adjustments to the original latitudes and departures for each course. Next, we'll calculate the double meridian distance values using the adjusted departures. As mentioned previously, the initial double meridian distance simply equals the departure of that course, 108.3 feet. For the other three courses, the double meridian distance for a course equals the double meridian distance of the previous course plus the departure of the previous course plus the departure of that course. And this process repeats for the remaining courses. Next, we'll remove the departure column and append a column for the latitude times the double meridian distance, which is calculated for each of the 4 courses, and all of these values are then summed together. Referring back to our equation to the area equals 1/2 times the absolute value of this sum of 41,111 feet squared. Therefore, the area equals 20,556 feet squared. After converting this area to the units of acres, the area of polygon ABCD equals 0.472 acres. When reviewing the possible solutions, the answer is A.